Ron event do this, but since the machine's root was not up last week, I'm just going to do it manually. And I've turned set-x on so that I can see what it's doing. So I've actually got a verbose trace coming out of my runAC script to tell me that I'm processing the data. And now it's generating my command summary, putting together my report, and now it's done. Okay, so turning on accounting created all this data, and then runAC processed the data to give me my reports. If I do it my LSLT now on PAC, I will see that I've got one file that's very small and it just started, 1358 being the date and time right now. So all that other PAC data is gone now. I no longer have it unless I explicitly saved it. So the PAC files are removed when I'm done. Now what that did do though then was leave all my data into var ADM ACK sum. And in there now I have a 17th, RPRT 1017. Okay. So if I take a look at that file, I can then see everything for this month. And I see things at the top like number of times I've changed run levels, number of boots I've done, things like that. I'm going from the 15th to the 17th. 15th was when I built the route and ran this for the first time. I can see top users, I can see what TNG4 has been running here. And now that I've got this run done, here's my top commands, code 421, code 2MP, code 3. So, now that I've got that newer data, if I pop up SPV, since runAC is run, there's newer information, including Sunday, Monday, and today. Oh, this is right in the room.
I kicked them off again, so it may slow you down a little bit.
Yeah.
Actually, there's idle space, idle time in here.
But you need more than CPUs to do things, like buffer cache and stuff.
Well,
So that's another example where the CPUs might be healthy.
actually, your buffer cache has been peaking up to 140 megabytes a second.
Yeah, well, we'll take a look at that. I'm just saying these could be good, but I may be waiting on other events, including networks and stuff. So now I'm going to go back to this ACK CMS and take a look at my CPU command summary, and this is going to be slightly different. Well, it looks like pretty much the same, except note the minutes are bigger now. Everything that I processed up till now. Let me see memory. So I'm looking at the same data this morning, but I'm including everything that we've had up till now. That looked okay. Byte. That's the same. Let me see if users changed at all. There we are. This morning it wasn't TNG4 and DAW, it was root and a few others. So now I've got 2653 minutes, whereas this morning it was like 1700 minutes. And now with all that additional time, I see TNG04 and DAW being the biggest users. TNG5 and 6 have also run a few things. And I no longer have accounting data because I just processed accounting, but I do have the ACK CBT data. Let's see if that's going to work. There was a problem with it this morning, but that was a permission problem, I believe. You have to be root, or in this case, I'm going to open up the files. Oops, that's my workstation. So now this is the same data, except this time I'm getting it out of this SAT data rather than the System 5 data. And this time now, besides the elapsed time components, I can also look at my wait times. So looking at our system right now, I see my service times, my system times, and my wait times. Here's my physical I/O waits. Code 2 is getting up to 2.5 minutes of physical I/O wait time, and almost 2 minutes. Code 2 is not getting any, but 1 and 3 have a lot of cached I/O wait time. So there's about 2.5 minutes typically of physical and 2 minutes of cache wait time. Let's see about our CPU waits. There's some Code 2s, probably when you're running a whole bunch of them, that are getting in the 4-minute range for CPU wait times. And on a per process basis, most of my system time is still less than 1/10 of a second. This is 10 to the negative third, so there's 1/10 of a second right there. So not a whole lot of system time yet. And then here's my CPU times. And here's all the code 2's. Again, these are all the exact same number of floating point computations, but they're varying anywhere from 33 to 36 minutes to get the same work done. And that is mostly secondary cache thrash effects. So let me just exit out of this. So I was using the PAC data for a bit there. Now to load the stuff, I had to have EUESW ACT loaded. No reboot is required. If that's not loaded, you won't have the check config flag or the userlib ACT directory and stuff. Second thing I did then was check config ACT on. And then here's the ITSI init ACT start and stop. No reboot required. And then also a cron tab entry example for run ACT, check PAC. And monac is the one that generates my monthly reports. So runac leaves all of its data in the sum directory, and then when monac runs, it leaves it in the monac directory. Actually, userlib act monac is this command, and there is a var adium act fiscal directory that it leaves it in. You might want to write that down there. Var adium act fiscal is where the monthly reports are. Now, all the sites I work with don't do monthly reports. They pull the data off on a daily basis and then do the monthly report across the whole data center on some other system. So usually they're just pushing it off to an accounting server every day, and then that accounting server does the reports at the end of the month. I just want to keep going here. Extended accounting was the other piece, that's the SAT data, and I was using that a minute ago. So I have to have EOESW audit loaded. This does impact performance. It will increase your system time, potentially. So this is one reason that we don't want it anymore, because CSA accounting is going to be better. Basically, loading this module means the kernel, every time it does an open or a close, is going to have to check to decide whether it's going to trap the event or not. So whether accounting is on or off, you still get the load. So you got to load with inst if not installed. This is another module that has conflict issues. So you got to open your overlay, then your base, to be able to resolve the conflicts. Then a check config audit on, and then it gets these config sat select options off all if I want all the other events off. But the two events I want for this class are proc and session. Now all these records are actually written through network mbuffs rather than file system buffer cache, and all the files are in var adium SAT. Now there's no scrubber for those files. Fell off the table.
Yep.
There's no scrubber for those files, so you may want to put a man page or a find in there to scrub everything. Now, the size that these files can get to will depend upon the number of events you're trapping. But I've seen sites that have a month's worth of data that need 8 gig just for the data. Okay? So it really depends upon how much you're trapping in terms of how much space these take. These will consume disk space very quickly. Whereas the PAC stuff did not, because it's much smaller. SAR was much smaller too. Now the other thing that I need to do though for extended accounting, this requires a reboot, is to check and make sure SAC is set to 1 and extended PAC is set to 1. Every now and then I forget that, reboot the system, and I don't have the data there. So you got to remember to set those to a 1. And there's a new one added now for CSA data. CSA PAC. Let me just show you that one. System-I. So there's this new one, do CSA ACT, for the third type of accounting data. So once I've got the data going, I've got to decide on an interval to pick. Now we've already got the data installed and everything. I guess the last piece was the CSA package. So I did a versions rep for CSA ACCT. So it's just like the others. I do have that package loaded. Check config. Shows that it's on. And then when I go into var ADM, ACCT day, there's the PAC files that I have. Here's the PAC file for everything that's been going on so far. In fact, let me try something, CSA-COM-W on PACCT. And I see all the different timestamps in there. So I've got 3 days in there. There's a Sunday, starting at 1649. Then on Monday, there's another file, or a date change in there. And at Tuesday, these are all on reboots. And the last record I have in there is current to today at 1408, which is the time I have right now. So that PAC file has 3 days worth of data in it. And again, the command to look at it is CSA-COM. I can page CSA-COM PAC, and now I'm looking at the name of the process and all the metrics that we were using yesterday to get these applications profiled. So I get my user, terminal, start and end times, the elapsed time, the CPU service time, and the average memory size. So I was using CSA-COM-N code-W for wait times in this case, and I'll page it. And now I can start to look at, here's code 1s, code 2s, and I can start to look at the CPU waits. Those are the service times, CPU waits, and the IO waits that I have here. And I'm just looking for something big. Here were some of the code 3s that took 36 seconds of IO wait time, but nothing for the CPU. 21 seconds waiting on a CPU. We did see some in that range. Note this whole group started at the same time. So some of them had 10 or 20 seconds waiting on a CPU. There's no I/O to them, so they were CPU bound. And here's another group. CPU waits in the 11 to 17 second range, but the I/O waits were still much worse in the 60 to 70 second range. Okay. So this helps me sort out my politics, and I say code 2s are what matters to me, so I've got CPU waits and I've got I/O waits going on here. Here's some code 2s that had 100 seconds of I/O wait. Okay. Now, I'm going to process the data. The command to do that is user lib act CSA run. Instead of run act, it's called CSA run. So this is going to take that data and now consolidate it into a report. And I don't have this SPV GUI to look at the data that comes out of this yet.
What's the file again? User lib?
User lib act CSA run is the script I'm running right now. The user lib act directory is usually not in a path because nobody really runs it in their default path. So usually I have to put the whole path there. Okay, I did have some sort of problem. I'm going to go into user. When you get errors with accounting, you go into the night directory. And I'm just going to tail FT. No, that won't have anything in it. Cat. Oh, I gotta go one directory deeper. CSA, and there's my errors. E, A, splat. That one's okay. And right in here, I had a syntactical error. There was a -X option specified on my command line. That was my mistake. I also have a problem here with the session file name. So let me fix this. CD lib. right now I've got a performance problem. The editor's handling itself real slowly. I can't even log into the system yet. The system is stalled, so to speak.
No, it isn't.
Okay. And if I had a window open during that event, I might be able to get some data. I don't. The event looks like it's over for a little bit.
Load's only 20.
And again, if I've been able to catch that event, note that I do have swapping going on. So I had 16% weight I/O, most of it being swap. So again, that event that we just experienced was an I/O event, even though it was there for maybe 15 seconds. Even though I'm not, my CPUs are pretty much full and being used, it was the I/O that I was waiting on. So let me try this again now, man. 6. Going on again. So most of my events that are occurring right now, I've got 30-40% weight I/O, half of it being swap, half of it being file system buffer cache. And the swap looks like more of a problem than the buffer cache right now. So that swapping is still causing me a problem. Let's see swap-ln. Note that most of my swapping is going on to root. I could delete dev swap. In fact, let me do that. Swap-d/dev/swap. I'm getting swap traffic off of root. Unfortunately, there's also that other file system, where was it? Right now we're busy pulling that 256 meg of swap space onto these other swap partitions.
KS0, yeah, you want to go to 6 to give you better performance.
If I bring that priority to a 6, that's what you're saying?
No, I'm just looking at your other swap devices. The DKS6 would take you off onto a totally different controller.
Agreed. They're just using all these spare slices on the different routes, and that's why they're there. Since I had several routes there, we just put them on to keep growing. But being able to distribute them across other SCSIs would help too. Let me see where I am in the workbook. I think we should take a 15-minute break here.
Wow. I think somebody else started something up. I don't know who it is. I didn't kick off anything new.
I could have been marooned or something. It looks like the load. Oh, this is on my workstation. That's why.
Well, we're at 90% CPU, all CPU user.
Oh, there's my swap is done now. I type in a SAR. I can look at those last few minutes that I've had here, the last 3 minutes. I/O wait time was very, very high, and it was split between swapping and file system buffer cache. The events that we were just experiencing looked like they were more swap traffic. Now if I do my swap-ln, I see that particular dev swap is no longer there. And I was also going to get rid of, where I was going here. Remember, there was a swap slice that was on my home directory. So S0D3 would be another swap slice that I would want to remove. And I'm also going to do that in FS tab.
PS storage, does that require some special software?
No, it just requires root.
Well, it gave me an error when I tried running on the machine.
On Do or your machine.
On my machine.
That's why it's not being supported anymore. The can't keep up with the newer disk drives. You may have a fiber channel on there that it doesn't know how to deal with yet. I'm trying to ask the Performance Copilot people to get that functionality in there. So I commented out that home directory swap slice too, so if I do get swapping, at least I can get them away from root and away from home. Okay. Now we need to take a break here. So let's take about a 15-minute break, come back about 25 after. So I'm just going to
And
try
where do you want
again.
it to go to? You want it to come to you?
Sure. So in this example, I'm going to run SPV batch, and I can put this in a cron event too, and then modify SPV batch to give me just the charts I want and to put things in the web servers directory and stuff. So I'm going to run this SPV batch, and now it's going to go out and get the system inventory and grab any data that's on the system. Top here.
What is that information about?
This is for that script, my SPV script.
Oh, okay.
So Warren wanted me to look at his machine, and there's firewalls in between, so I can pull off the data, and right now, you've got the system inventory, and now it's going through and generating all my XGraph charts.
Okay.
So that data I was looking earlier today with the high system time, I sent them these two scripts, they ran it, and then all the output is put in temp $log name SPV. So you tar up that directory, and however you want to mail it back or whatever, for email, I usually encode a tar file and then mail it to the person. Or depending upon your mail handler, like Netscape or something, just do your normal attachment. So now it's going through and looking for any data on the system. It's going through SAR data right now, and it's going to try PCP, then accounting, then SAT data. No CSA data is being handled by this script yet. That's what I was working on last week, as a matter of fact. So now it's going through the accounting data. Generating the pie charts, top commands, top users, top groups. I was doing PCP. And all this data is going into var, or I'm sorry, /temp. In my case, /temp/DAW, SPV. And in there is this SPV_reports directory. And these are all the charts that's been generating. So I can now do an XGraph on memory utilization, for example. Oops.
No, I think I've been caught by the campus police.
Do what?
What happened?
The copy isn't going.
So this is the data off of do where I can see my memory utilization. These are when we run the code for us. Unfortunately, the lines aren't very thick right now. But here's my kernel down in here. Most of my memory has been used when I fire off these code 4s, and this is when the swapping is occurring. Let me do that a little bit easier here. So the background is white. Isn't as easy to see. A line width that's thicker. So since Sunday, here's what the workload looked like, and here's all the codes that we ran yesterday, and today we've been firing up the workload a little bit more, and we can see that most of the memory is being used by users. The kernel is not getting very big here. That's because NBUF was set very low, 400. little bit later in the week, we're going to upend buff, and then we'll throw I/O loads at the system and watch the cache grow. So let me see if that script is done. Still going, it's going through SAT data right now. Now it's giving me my top commands. And it looks like there's a blow up that I should check on. Well, that one's okay. Par. Fix that. So I could put that SPV in a cron tab, and again, /temp log name SPV. And then I've got my reports directory, SPV_reports, that has all the data that I just generated. CD into SPV_reports. I can do an extract, background of white, line width 3. Actually, let me do this one. No lines, capital P, and find a SAT one.
That means SD.
Let me go with expansion factors. Oops. Okay, so here's what I've got from the SAT data showing my main codes again. Codes 1, 2, 2MP, 3, and 4. So here's code 1. So these are the expansion factors now. Wall clock over service. So some of these are coming in very good. But look at some of them are coming not too bad at 5-to-1 ratio. So some of these are 5 times wall clock over service. But codes 1 and codes 3 are not doing so good. Codes 2 are doing real good. Their wall clock and their service are very close to each other. We're just a little bit between 1 and 1.2. So these are acceptable. Code 2MP was very, very good. Here's my code 3s, not too bad. And then here's my code 4s up here. And then this, no, I'm sorry, that was code 3s. Here were the code 4s. And a couple of CSA builds in here. So SPV just allows me to, I like to call it a Vegematic. It slices and dices these different data sets. Now at this point, I'd like to go back to the workbook. So I want to make sure, when I pick an interval now, I want to make sure that the data's there and good. And yesterday we had to change NQE, so that destroyed some of my data records from yesterday. When I'm looking at an interval, I want to make sure it's a fair representation of the typical interval. If they call me and say they're a Nastran site, and I look at the system and find mom's budget, I don't want to worry about mom's budget. I want to worry about Nastran. If they're crashing cars, I want to look at an interval when a car crash is occurring. I do not want to pick New Year's Eve. I don't want to pick the last day of the school quarter. I want to pick a repeatable interval. Okay? So in my evaluation process, I ask the customer, what are your top applications? And then with SPV, I see what the top applications actually are. And if the two of them don't correlate, then I tell the customer, you're not running Nastran, you're running mom's budget. And Janet laughed, but I actually found that name of a program on a system out there once. Somebody was running a program called mom's budget. That was a policy decision. They told the person, don't do that on this compute server. Do that on your workstation. Okay? Or maybe I just find top running all the time or something like that. But you want to pick a repeatable interval. You want to make sure that you got some data. I can't advise somebody how to tune their system if I looked at 5 seconds and there's been a lot of months in the past year that they've been using their system. I generally do not want to pick an interval near a reboot unless I'm tuning for a reboot. As a system tuner, I might be interested, like on Windows, how quickly can I get Windows to come up? But on compute servers, you generally don't interrupt them, so that the start and shutdown times are not that much of a concern. Any suggestions on what would be concerned in starts and shutdowns? We hit them yesterday too.
Mission critical stuff.
What I was looking for was NQE checkpoint restarts. So when I'm shutting down the system, some sites will tune to make checkpoints and restarts go quicker, which usually means they create a separate file system to dump their NQS checkpoint files onto. Okay. So yesterday when I shut down and we had code 2s running, it took a little bit to checkpoint all those code 2s. So that might be a case where you do tune in a reboot situation.
If I remember right, though, the checkpoint that didn't restart it.
We can look at that. It should have restarted it, but whether it started it from the beginning or started it from a restart image, we'd have to check the logs for that. It should have restarted from the last checkpoint image, but if it wasn't around long enough, there might not be a checkpoint image yet. Also, when I'm picking an interval, I want to check the syslog. I do not want to tune when the file systems are full, things like that. I want to solve the syslog error messages before I start making system configuration changes. So if I see disk fulls or memory processes killed, I want to solve that before I go on to anything else. I do not want to make tuning decisions based upon hangs, crashes, or service problems. If I've got an unstable system because it's pre-release or something like that, I want to look at those as stability issues, not tuning issues. Another thing, looking at a system that is oversaturated. We've experienced that twice today at least already. At some point the system is so loaded that you can't get anything out of it and you have to wait until after the event is done to see what happened. Now what I'm saying here, if I'm tuning a system, I have to be very careful about the data that I'm looking at. Now is as good a time as any to introduce this. We talked about it yesterday, called a bottleneck curve. That's what we're talking about here. Where am I on my bottleneck curve when I'm looking at my numbers? So does anybody remember this from yesterday? Down here was the number of what I'm calling a workload unit. That's the generic term for it. The workload unit could be a process, could be a thread, could be a user, number of users on the system, could be number of codes. Okay, number of car crashes. What is my workload unit on the system? And then over here was my elapsed time, or expansion factor, which was my quality of service metric. So every computer has a bottleneck curve. I don't care what the computer is in your lifetime and my lifetime, they always have bottleneck curves to them. They always will, because every computer will always have finite capacity. We can't deal with infinity. Okay? So down here is unity, and this is where the benchmarkers like to run things. One thing on the system and my wall clock and my service are identical. As I drive up the load on my system, I have to have a degradation in my quality of service. And eventually, I have to end up at infinity. Infinity says I never got my answer back. We've already had that happen with code 4s. Code 4s died because they ran out of memory. Okay? So, on every system, there's going to be some sort of bottleneck curve. The shape of the bottleneck curve is something that is different in every situation. Depends upon the hardware, the applications. Every bottleneck curve has a different shape to it. I've just picked a rough bottleneck shape here. Now we used to call these bottlenecks because they used to be real curved, like that. But that's when we had 1 or 2 CPUs. Now that we get in over 8 CPUs, bottleneck curves have a more complicated shape to them. So, if we were looking at CPUs, so this is the CPU bottleneck, at some point, processes start dying. What limit is that going to be? System-wide. What's going to set infinity? nproc. I cannot have more processes than nproc is configured. That was that 32676 that we saw earlier. I cannot have more processes past that. Then we get forks denied and things get shut off and basically processes are aborted and we never get our answer back. That's infinity. If it were memory, then that'd be my virtual memory size. If it were disk, it'd be the space of the disk. As my disk fills up, eventually I get no space left on device. And that's infinity again. I never was able to finish. I aborted because the resources ran out. Now, as I'm driving up the load on my system, there is going to be a point where I have a very definite bump in my service times. And this is based upon the number of CPUs you have on your system. Once I've got more programs than CPUs, they have to share secondary cache. And we're running a little late. We're going to get into cache misses and secondary cache issues first thing tomorrow morning. This stuff here is from L2 thrashing. Due to system demons and just the noise and chatter on a system. This is why we don't like interactive users logged in, because they come in for a tenth of a second, kick somebody out of the CPU, mess up the secondary cache using it with its own data, and then when that code 2 comes back in, it has to rewarm secondary cache with all of this data. So L2 thrashing is when I lose affinity to my CPU, somebody else comes in, pollutes secondary cache, and then when the scheduler puts me back on that CPU, I have to reload secondary cache with all my data. Past that then, we have L2 thrashing, but we also have CPU wait times. So as I get more processes than CPUs, somebody has to wait. So my CPU wait time starts going up when I get over the number of CPUs in my system. And we've experienced that a couple of times now where CPU waits were going up in the 30-second, 40-second range, but they were still not as bad as the IO wait problems that I had. Okay. Now just going back to this comment, if I'm looking at a system that is oversaturated, the point that I'm trying to make here is if I'm looking at a system that's operating in this portion of the bandwidth of the curve, and I trace that up, I have a larger variance in what I see over here. In other words, a small change in my load can smear my numbers and cause a big change in my numbers. You actually get distortion of your numbers. So at some point the machine is so overloaded that even SAR cannot get the I/O buffers it needs to write a SAR record. And 10 minutes later you see SAR get 3 records in there that should have occurred in the past 3 minutes, but it couldn't get a buffer to do that. And then all of a sudden it got a buffer, and so did the other 2 SARs that were, queued up to get a buffer. Now this burned me at NASA Goddard because I'm sitting there looking at the system and my elapsed time is going all over the place and my service time and wait times were staying the same. And what was happening was when the process terminates, it then asks buffer cache for a buffer. Now the counters had already stopped, but the elapsed time is after I grab the buffer. So in this case, when my buffer cache got oversubscribed, my elapsed time kept going, but it was not counting the I/O wait time that was after the process terminated. So I'm sitting here saying, I had a 20-minute wait on a man page, and when I looked at accounting data, I could only see 3 minutes of actual work there. So just to reinforce my point is, when the machine is oversaturated, a small change in what's going on with the system can have a smearing effect and distort my numbers, causing a big change in what I'm seeing over on the other side. And out of curiosity, let's see what SAR is showing me. These are all coming in at 6 or 7 seconds at a time.
Dave, what
Yeah.
is the path for SPV?
It's in my bin directory, ~DAW/bin.
Oh, really? So, if I do just SPV, why? Say command not found. It's kind of weird.
It's probably not in your path.
It's in here, right?
You may not have current directory in your path. So /SPV.
Oh, okay.
Or ~DAW bin SPV. Not sure why it's taking so long there. I'm trying to demonstrate this effect, and here was an example where my system got loaded. I had severe I/O wait experienced here, and look at what happened to my timings. They were typically 7 or 8 seconds after, but suddenly it slipped and there was a 20-second difference or so in there. So between 1412 and 1413, SAR could not get a buffer to get that actual record written in there. It waited 20 seconds longer than it should have. So because the machine was oversaturated, I got a smear there. Here's one that was 46 seconds. So it was 40 seconds late. And in this case, because I see that it's wait I/O, and it's a combination of buffer cache and swap, the I/O contention was causing it problems, and it was taking 20 seconds and 40 seconds longer than it should have just to get a buffer to write I/O. So this is an example where the system started smearing because of the load on the system, because I was operating in a high portion of the bottleneck curve. Now, one of the things I do, this week I got somebody using the machine off hours, but if I had the machine up all night, I've got a script called go.bottle, which actually measures these bottlenecks, and then I can actually plot what the bottleneck looks like. And I'm going to show you some of that data tomorrow morning. In every OS, the shape of these bottleneck curves change all over the place with each OS. Okay. So anyways, the other thing is to pick an interval that has a clean beginning and end. In benchmarking, that's easy. I turn on the machine, I throw the workload at it, workload finishes, I now have a clean start and end. Also, some people choose the interval based upon the start of, if I see with SPV, some metric goes up and then back down, I may look to see what other metrics are going up and down with it. Now, all this is trying to say is that with accounting data, I do not see the accounting records until the process terminates. So if I have a program that runs through the whole day, it's called a spanning process. Or I may have had a process that ran for 3 months and then ended in that day. These are the ones the data center manager likes because they get more utilization than they have capacity. Also, if I do a checkpoint with the kill, that also results in an accounting record being written. Just the kill. So when I shut down NQS, any job that is checkpointed will have an accounting record written for it. Now, ACCOM and CSACOM, these 3 commands, ACCOM, CSACOM, and ACCBT, only show records that ended in the interval. If something started in the interval and finished the next day, we would also not see it. Now, this is something that data center managers do. They go to my accounting data. So this was an example. Now, this particular example, it was a 32 CPU system. And I looked at it for a half an hour. Okay. So at the beginning of the half hour, I did a SAR-U and I did a PS. And then at the end of the half hour, I did the SAR-U and PS and identified what was going on during the interval. So the picture I had on the previous slide, this is actually doing the arithmetic that we just saw. Now, SAR-U, let me back up a second, 32 CPUs times half an hour. So let me get my calculator up. So half an hour would be 60 seconds times 30 minutes, 1800, times the number of CPUs I have on my system. So that half hour had the capacity of 57,600 seconds. Okay, and that's what I got down here. So that's the capacity of my system in the half hour. The number of seconds times the number of CPUs. Okay. So with SAR-U, I found out that I was 78% idle during that half hour. This was not a very good example. I would have preferred more work running. So 78% of 57,600 was 44,982 seconds. When I looked at ATCOM, I found 612 records there, added them up, and got 8,605 seconds, which was 15% of my capacity. Now, the data center manager might look at the data at the end of the day or the month and say, I only see 15% of my machine. What happened to the rest of it? Because they didn't count idle and they didn't count other processes. So it's very common. I get this about 6-7 times a year where some customers comparing SAR and accounting. And they want to say, do I have this 57,600 seconds accounted for? And it's called the capture ratio. So without taking care of idle and edge effects, they had a 15% capture ratio, and the administrator, data center manager says, what happened to the other 85% of my machine? And without doing this, they can't account for that or charge for it. And I also had 43 processes that ran through the interval, added up with by hand with PS, got 3,557 seconds, and that was 6% of my interval. That left me 25 seconds that I didn't know what happened to it. And it gave me a 99% capture ratio. So data center manager at the end of the month takes the number of hours times the number of CPUs and says from the accounting data, can I account for that interval? Okay. And if I took my example with SPV, when I went into the counting data, one of the things I want to check is what my capture ratio is. So when I go to this ACCMS report, down here at the bottom, I've got 20,037 CPU minutes that are now accounted for. And then I'd want to know what interval that is. Now this is only about 3 days worth of data. Sunday, Monday, Tuesday kind of thing. Times the number of CPUs. So this number is saying, here's what I account for. If I saw 1 minute, I would say I don't have a very good sample. Okay, and that's all because of edge effects. That's because programs do not write accounting records until they terminate. So accounting for the spanning one added another 6%, accounting for idle added 78%, giving me a 99% capture ratio. I'm going to skip over this slide, a couple of slides that I skip over all the time. Now this is where we're going next. So, this is what I had up on the board earlier. If I have high CPU time, Perfex and SS Run are going to tell me about it. That's where we need to go next, is get into running code 2 with SS Run and Perfex. And based upon time, I figure Perfex would be first thing in the morning. If I have high system time, then I said go to PAR. And we're going to talk about a few other commands that are available as well to look at high system time. So SAR-U told me what to look for. I talked a little bit about a memory integral. We'll come back to that a little bit later as we need. These things here were memory integrals. Average memory size, 16 meg, 22 meg, and 400 meg. That was gotten from the memory integral. And what we do there is take the integral and divide by the CPU time, and that gives me the average memory size. So that's what accounting was giving me, was this. And not the virtual size. And again, in extended accounting, standard Unix accounting combines I/O into total, but I like to separate reads and writes out, because it matters to me. Reading is cache, writing is buffering. So in the extended accounting data, or CSA, we keep them separate. So I can say reads, writes, all separated. And with SPV, I can get what's the average request size, bytes moved per second, and things like that. So I get derived metrics. I can say, am I reading more than writing, or writing more than reading? How much is going to disk? Am I upside down in my cache? I'll talk about that later. I get my average size. So if I take characters read, divide by number of calls, I get an average request size. Average blocks to disk. And then my last two metrics, what's my I/O transfer rate? Bytes moved times I/O wait seconds. And this is a unique metric that I personally use. I don't know of anybody else using this. But it's I/O intensity is what I'm calling it. There's no standard for anyone else. This is a convention I'm trying to enforce. And there I'm taking bytes per CPU second. So I could have an application that has a high I/O intensity with large amounts of bytes being moved on a per CPU second basis. These are the ones that dominate your buffer cache. So the ones that have high I/O intensities are candidates for the ones that are holding cache buffers, because they're using a lot of them and they're CPU intensive. When I mentioned 20-minute waits on a man page for NASA Goddard, my analysis identified a program that had high I/O intensity rates, and that turned out to be the program that was causing the buffer cache contention. And if I got SPV up, under the SAT metrics, max CVT. Down here, I've got my IO intensities. So let's see what I come up with for programs that are high IO intensity. They're moving a lot of bytes per CPU second. Not too bad. So down here, just to get down to my actual data, the one that has the highest IO intensity is code 3. So code 3 is moving the most amount of data per CPU second. And that would be the first candidate to be consuming my buffer cache and holding the buffers, marooning the interactive user and causing 20-minute waits on a man page. Whereas code 2 does no I/O, so you see those down here right at 0. Code 4 also did no I/O. And code 1 was middle of the road. So remember when I characterized these, I said code 3 was big I/O. It was small in memory, only 3 meg, but it moved 368 megabytes in 60 seconds. Okay. 60 seconds of CPU time. Get out of that. So that SPB command will generate these sorts of metrics for you so that you can see them. And then these were the ones that I was complaining about. Run CPU wait time, we were tracking, those looked okay, but these were the two that were distorting on me. It should have showed the buffer and the buff lock, but I was seeing a lot of BIO locks going on. I'm going to have to investigate that. I've been running these codes on Origins for 4 years, looking at the data, and then I've generated a report here and I see the I/O raw times higher than the cached I/O wait times. But then when I ran PS and saw with ksync name D the BIO locks instead of the buff locks, it's telling me that the kernel has had its code changed and those locks now are moved or whatever and they're being timed differently. But the buff lock used to be cache, and then direct I/O lock was for direct to disk, O_direct type of I/O. So in 659, 6510, you've got to start watching these two numbers. They seem to have changed in the way they're being counted. And I'm going to have to send email to people and find out if anybody else is paying attention to that. Usually I'm the first one to see these sorts of things because that's what we're stressing in the class and then looking at the actual data. And I've got a reference because I run the same job mix every time. So I know what the program should be. Now, in past, some of this showed up as swapping too. So if I started swapping, that was also added into the buffered I/O or the direct I/O times. And that has also changed. So for a while there, I got in trouble with a couple of people because the code had changed and I was still talking about the older style. And that was having to do with page cache and buffered I/O wait time. When I got pages that were stolen from page cache, it actually showed up as buffered I/O wait time. And now all that lock, the kernel code to do that has changed significantly in the last 2 releases. So we're going to come back to that, but all this data was SAT or CSA accounting. What command was I using to get them? Let me just use CSA com-w, page it, and there they are. There's my CPU wait, my run queue wait, my block I/O wait, which was through my cache, and then my direct I/O wait, which was bypassing cache. So this was the buff lock, and this was the BIO lock. So that W command gave me the wait times. Also, there is a command you might be interested in, XACTL, session info. This prints out my session table. XACTL session info will print out the accounting statistics for my particular process, for my particular session. So here I've got an example. Ever since I've logged in on this interactive session, I see a project ID, total ticks, start time, and here my user time is small. My system time is a little bit larger than that. Then I've got some block I/O wait time. Then I've got raw I/O wait, and then I've got CPU wait. So right now the system time is the worst. Then I've got the block I/O wait time, and then the run queue wait time. And this is waiting on file system buffer cache, What I'm surprised at is seeing the raw IOA kicking up. Normally that has been 0 on older releases. And again, that's the way that counter is being counted. So this XACTL gets to the data that's actually in the kernel session table to print out the same numbers that then get written into CSA records or SAT records. This is the live table, and then when the process terminates, we copy the stuff into the CSA file or into the SAT file. I'm just going to skip over this right now, but if you get too tight of an interval, you get too much data. And in terms of accounting processing, again, all of our data is in VAR-ADM PAC. RUNAC processed it. I ran this earlier, and in the night directory are all my diagnostics. And then when I'm done, RUNAC leaves data in the sum directory, and this is what SPV was going for. So it pulled out the ASCII report. We briefly looked at that. And then I've got the CMS binary files and the user binary files. The TAC file contains top users. So if I want to charge people on a per user basis, TAC tells me how many CPU minutes each user has used. And then MONAC takes those sum binary files, CMS and TAC MMDD, consolidates them into a monthly report, and that's put into the fiscal directory. And again, most sites don't run MONAC. They probably should, because MONAC will scrub the older files. So I don't want to spend any real time here, but in the workbook then are samples of these different reports. And SPB was visualizing it for me. So the pie charts that I saw, I grabbed the total CPU time here, normalize it to the total, and then convert them into percentage and put that into a pie chart and say, of the total, how are my commands? What are my top commands? So as a system tuner, the ACT-CMS command is very important to me, because that'll tell me what are the top CPU, top memory, and top I/O programs. So we get name of the program, number of times, the number of records in the file for that. We get memory intervals, CPU times. We get elapsed time, average memory size, average CPU time. The hog factor I mentioned. The hog factor says what percentage of my wall clock time is CPU service. So at 99%, for example, here, fine. The CPU time was 0.16 and the elapsed time was 0.16. So that gave me, with rounding, a 0.99% interval. So when I'm tuning a system, I want high hog factors. Whereas the interactive user says those with high hog factors are the ones that are hogging my system. So in the workstation, they're the ones that might be bad and taking your CPUs. But some of them could be sleeping all the time. Let's see, the shell, 216 of them. Elapsed time, well, not very good here. 0.07 seconds of CPU time and 0.01 and 0.13 seconds of elapsed time. And that gave me a hog factor of 0.05. SADC was even worse, 0.18 of CPU time and 2,000 seconds of elapsed time. The last two fields then are the data moved and the blocks read and written. So characters transferred are what I asked the kernel to do, and blocks transferred are what the kernel pushes out of cache. So that's the back end of cache. The other command then we used yesterday was ACTCOM. So that gave me command name, username, things like elapsed time, service time, data transferred, and also my memory size. So this was basically what I was doing yesterday to get the data that we had there. ACT-MERGE is the top user reports. So here, for example, guest is showing up here as interactive connect time. But for example, we've got root here, 2512 minutes of memory use. Not a whole lot of CPU time here, it's kind of empty. Also, disk space consumption is in this report. So I see that I've got 6,454 blocks that were sampled, and I did the sampling 16 times. So I ran accounting 16 times and got a total of that number of blocks. So then I can charge people based upon it. Again, that was also SPV, putting this into a pie chart. Now if I go into SAT data, there isn't SAT interpret command, but I now use ACT-CVT instead. But SAT interpret will print out my accounting records. The trouble is I don't like numbers that I can't slide my decimal points over, and it's not human friendly in a column. So I rewrote SAT interpret and called it ACCVT. And then in ACCVT, I've got an ACCOM type of interface, but additional parameters that are available. Just to keep going here. Workload categories. When I'm consolidating data down, they're going by category. So everything that is a sleeper, like the shells and the compilers and stuff, sleep all the time. They go into a category called shepherds. They're the ones that sleep all the time, very little CPU work. I go off to lunch, my shell's still going. Then I've got what I call the standard Unix small processes. These are LS, PWDs, the little stuff you do, the date commands, unames, all that sort of thing. They're typically less than a second or two. And elapsed times 5 seconds or less. Then I've got interactive ones that are tied to a terminal, VI, edit, mail. Then I've got administrative commands, like we already saw the CSA command showing up in my report today. Top, or any sort of operator displays. I may have a category for diagnostics, such as FX doing surface analysis or something. And I do create a separate category for compilers. BE and LD, for example, do lots of little IOs and are fairly big in memory. And I also create a category for file system backups. So the ones that are doing dumps, tars, and CPIOs are often big IO, and I put them into their own category. Now there are products out there that will take the accounting data and categorize them and put them into accounting buckets based upon program name. The TeamQuest product is an example of that. They have what's called a workload definition interface that we work with them on to specify if the CPU time is this, if the command name's this, put it into this bucket. So you can actually take all your accounting records and say, based upon these records, put it into this account. If I were an accountant, this would be called a ledger account name. Okay? So when I write my checks, I use MS Money and I say food goes to groceries, or a store called Rainbow in the Twin Cities is where I buy my food. And every time I write a check to Rainbow, it goes into the category called food or groceries or something like that. Okay. Besides these categories, we also have those categories for our applications, but these are the ones that would be on a normal system without the batch workload.